All right, yeah, so it's Martin, I'm Marcus. We're here from Meebo. This will be a pretty technical talk, and we're trying to leave time for questions. So if you have any questions during, then just remember them and ask them afterwards. All right, so Meebo is pretty well known for Meebo.com. That's what most people know of Meebo as. Meebo.com is an IM aggregator on the web. However, today, Meebo is really better known for the Meebo bar. The Meebo bar is, well, if you have a site, then you can put the Meebo bar onto your site and get a bunch of features. As you see, that whole stack of features, IM sharing, there's ad revenue, customization, and so on. We have built the Meebo bar and iterated on it for about 2 years now. About 2 years ago, we launched the first version. Since then, it's been adopted on more than 6,000 websites, and it reaches more than 100 million people every month. So the Meebo bar is what we call a third-party web app. We define a third-party web app as JavaScript, CSS, images, and HTML that get loaded onto a site from a third-party provider. Straightforward enough. They commonly interact with the page to add functionality, and most of the time it loads on every single page. It is very important that we ask ourselves as third-party web app developers, how can we make this run fast? And how can we make it respectful of the environment it lives in? Because it's not ours. If the Meebo bar is everywhere on the web, and it slows down the websites it's on, it slows down a significant portion of the web for all users, which is not good. So for third-party web apps, the challenge really is provide lots of features, load lots of features, and load them fast so that they're available for the user right away. But do that without blocking rendering or loading of the page, and without affecting the user experience in a negative way. It turns out this is trickier than it seems. I bet a lot of you know a lot about it. Martin does as well, so I'm going to bounce it over to him. How do we do this?
Great. So we're going to talk today about many different tools and techniques that we've either developed or used in creating the Meebo bar. A lot of these tools and techniques you're already familiar with because they're the same ones that you use to make websites run faster. So we're not going to spend a lot of time on those since there's plenty of literature out there already on that. You're already familiar with things like gzip and putting your content on CDNs, minifying your images in JavaScript. That sort of stuff is pretty well known. We're going to talk more about techniques particular to web apps that are running a lot of JavaScript. So we're going to talk a little bit about JavaScript profilers and compilers and some of the latest browser APIs that you can use, like local storage, vector graphics, data URIs. We're going to spend most of our time talking about the techniques we've developed with the Meebo bar. These include, first, how do we initialize a web app? So how do we get these web apps running on a website? What do you hand to a publisher when a publisher says, I want to run this web app on my website? And the key things there are you want it to be asynchronous and non-block, and you want your web app to start without interfering with the page. If your server goes down, you want that code that they put on their page to run and execute, even if your server's not there, and not fail or break their site or anything like that. Then, once your web app is loading, how do you keep the JavaScript from interfering too much with the page? How do you minimize the impact while it's loading? And how do you defer? How do you choose what to defer in your algorithms and how you lay out your code so that the JavaScript is running efficiently with the website that's behind it? And then moving on from JavaScript, we'll talk a little bit about CSS and images, the other resources in your web app, how to combine those to minimize the number of HTTP requests, since HTTP requests are one of the limiting factors when it comes to loading this extra content. It really slows down the website when you're loading a lot of images or CSS files. And then how to avoid images entirely. We'll show some examples of vector graphics. And finally, we'll just talk briefly on some perceived performance, because no matter how fast your web app is running, according to these automated tools and tests, and no matter how many of these techniques you use, if your performance seems sluggish to the user, then people are going to complain, and no one's going to want to use your web app. So getting started, we're going to talk first about the code that is used to initialize a web app. Just to give an example of embed code that works well, we've developed this code since we started the Meebo bar for 2 years. Right now, it executes in about 10 milliseconds. It's not blocking on any network requests, and it doesn't depend on our server. So if you put this code on your site and our server's gone, or the client just can't reach our server for some reason, your site won't be affected besides this 10 millisecond overhead. It's really small. It's about 1,200 characters, and it goes directly in the page. So it's not loading any external resources. You can include it in your other JavaScript files that you normally use for your site. How do we build an embed code like this? How do we make it so that it's definitely not going to break the page in any way? For a web app, the goal is to load a large chunk of JavaScript. So this embed code that you hand to publishers needs to get this large piece of JavaScript up and running. How do you do that? The obvious way is to create an inline script tag in your HTML. In your HTML, you just write a script source equals with a link to your external JavaScript file. This is actually a really bad idea. A number of third-party tools do this, but the problem with this is that this will actually block your page. It'll block it in many different ways. First, no other scripts are going to execute until this downloads and runs. Second, nothing else on the network can actually start downloading, so you can't get parallel downloads. So it's blocking not only the rendering, but also the network. Another technique that you can use is to use an iframe. It's very similar to the script tag. It's more designed to load an HTML file, though. It's nice because iframes are asynchronous by nature. Things loaded inside them don't affect the rendering and downloading of the rest of the page. But they actually do affect it a little bit. For one, the onload event of the page will block until the iframe has finished downloading. So if you put iframes on someone's page and you take a while to download the contents of the iframe, that page's onload event won't fire for a while. And users will actually see that. The status bar will say, waiting on your domain. And then people will think that your code is slowing down their site. XML HTTP requests are great for normal web apps if you run the same domain, because XHRs only can pull code from a server on the same domain as the main page. So they're not really applicable to third-party web apps. And finally, the commonly accepted way of doing it right now is to use a script tag. Create a script tag in JavaScript and append it to the head of the document. And this loads the script without blocking in most browsers. It turns out that this isn't that great, so we'll see why that is. First, let's just look at how this technique works. You write some JavaScript. It gets a reference to the head of the document, creates the script element, sets the source of the script element, appends it to the head. Your script is downloading asynchronously, and everything seems OK. It turns out in Firefox, this can actually block the browser from rendering. And the reason is because Firefox executes all scripts in order. So if you append the script to the head of your document, and there's a script tag later in the page that's going to do a document.write or create some content, that script won't run until the script that you've appended to the head finishes executing. So even though in most browsers it seems OK, in Firefox you're actually going to have a problem. And this is sort of solved in newer Firefox versions with a defer attribute. But not everyone's running the latest Firefox. So additionally, it blocks the onload event, sort of like an iframe. If you append that script to the head before the onload event of the main page, the onload event of the main page won't fire until after that script is loaded. So what other techniques can we use to load these large script payloads to initialize our web app? What we've chosen to do is take another look at iframes. Iframes are great because the content is loaded asynchronously. The drawbacks, as I mentioned before, are that you're loading HTML, not JavaScript. Cross-frame communication is difficult when you're doing that because the HTML page is on a third-party domain. And without post message, it's pretty hard to get that communication going if your web app needs to communicate with the parent page. And also, the window onload event blocks on all iframes. So our solution is create the iframe, but don't put anything in the source of the iframe. Instead, open the document directly and write out the HTML. What we end up with is the same domain iframe, and we're going to use the standard append a script tag to the head in the onload event of the iframe, except this time the script is getting appended to the head of the iframe, not the head of the main document. And that will actually keep the browser rendering things after you've created the iframe and while your script is downloading. And it will keep the script by appending to the head from blocking. So you can see what's happening in this chart here is the page will start rendering. The iframe is created. The trick here is that we call document.close, and that fires the onload event inside the iframe. It says there's no more content for this iframe. The iframe is loaded. What that means is the page can continue rendering, and the window onload event can fire. Meanwhile, in the iframe, that onload event is also causing the script tag to get appended to the iframe's head. And that gives us an asynchronous, non-blocking script download. A few more notes on iframes. There's a lot of talk that iframes are slow. Since we're only creating one iframe, it doesn't actually matter that much. You're only initializing your web app once. And creating an iframe in modern browsers doesn't take very long at all. Second, you actually get a benefit, which is that your JavaScript is sandboxed. So you don't have to worry about other people modifying your JavaScript prototypes or colliding in with your namespaces. So this is code we've been working on for a few years, and we highly recommend that everyone use a technique like this to load your scripts, because otherwise your web page that you put your web app on can be blocked when your servers are slow or when your servers go down.
Cool. All right, so now we have this pretty neat technique to load your JavaScript code truly asynchronously and non-blocking. Are there anyone here from companies that do load JavaScript onto other people's sites? I mean, yeah, 10, 15, 20. We strongly recommend looking at this. It takes care of two really big issues. All right, so moving on. Once you have this asynchronous loading, and you have your code loading on the page, it doesn't mean that you won't be slowing down the browser, right? Your code can still be slow. So there's this interesting or very important concept of deferring your execution, especially if you're a third-party web application product. The reason is that during onload, there's a lot of stuff going on in the browser, right? You load the page. What happens is it downloads everything, network traffics, and then it starts parsing. And then it builds a DOM, it builds a rendering tree, it starts laying out and rendering the actual viewport, right? Like, a lot of things happen. But more importantly, once that's done, very little happens. So let's say you have a chunk of stuff that needs to happen at some point in order for you to provide the service that you deliver. If you have it happen during this process, you will be slowing down the experience for the user, right? It's plain and simple. Oh, and the reason why that is because the browser is single-threaded, right? You'll have UI and JavaScript living in the same thread. So if you run JavaScript, it takes a long time. While the browser is trying to render something, the rendering won't happen. But if you let the browser finish and then do your work, then you're fine, because usually relatively little happens. So we're going to look at 2 or 3 examples of how we do that at Meebo and how it can make a difference. So this is the Meebo bar on a demo site. Any site with the Meebo bar on it has the choice to make images and links and videos shareable by drag and drop. Has anyone seen this before? Yeah, a couple? OK. The way it looks, well, OK, so the Meebo bar loads on the site. What it needs to do is it needs to scan the page and find all these elements that should be made shareable. And then when the user starts interacting with this page, for example, hovering over that image, then Meebo displays a drop shadow around that image to indicate to the user, this guy is shareable by drag and drop. When the user then does a mouse down and start dragging, we display the sharing UI, where the user can then share that piece of content, the image in this case, to any of their social networks or anybody in the buddy list. The metadata that you see in the little drag objects in the center of the page is a title, a thumbnail, and a link. We need to find that information about every item on the page that is shareable, right? So that when we send this over to, say, Facebook, then it shows up with an image, a title, and has a link that when you click on it takes you to the page where this came from. In order to make it easy for the site to kind of customize the sharing experience, we allow for them to specify the URL and the title and the thumbnail as attributes in HTML DOM element, in the HTML. So that if there is a Meibo attribute saying, for example, Meibo title should be foo on a parent element on anything that's shareable, then that shareable element should get foo as the title once you share it. So let's look at a naive implementation of how you would do this. And this is actually how we did it in the first iteration. So, all right, what's going on here? You get a function called makeShareable. We're going to run this function when the page loads in order to make all the elements shareable as soon as possible. This function takes an array of elements that should be made shareable and then runs lookup metadata on that element. Lookup metadata then inspects that element and all its parent nodes to see if there's any metadata specified on that node. It then goes ahead and attaches the mouse down event on the element as well to make it draggable. So if the Meibo bar loads fast enough and runs this fast enough, then it might happen during the rendering of the page, which will slow down the page significantly. This particular implementation has a formal runtime of O(n) times m, where n is the number of elements and m is the number of parents of the elements. Bad, right? So if we apply the notion of deferred execution to this and try to do as little of this as possible up front and as much as possible of it when we need it, what would that look like? This is a deferred implementation using event delegation. So initShare is a function that gets called when the page loads in order to make things shareable as soon as possible. Instead of looking up the metadata for all the elements right away, it just attaches a mouse down event to the document, right? The entire thing. So that anytime the user goes mouse down somewhere on the document, it looks to see, is the element that the user mouse down on shareable? If it is, then go ahead and look up the metadata for that element. Does that all make sense? Cool. The important point here is that the runtime on load is constant. It is not going to impact the loading of a page in a significant way. Then, after the page has finished loading and the user mouses down, that looking up of the metadata of a single node is trivial. Won't be noticed. So that's one example of where deferred execution of your code can be really, really powerful. And again, this can be used for regular web applications. The Yahoo homepage, I believe, does this really efficiently. Right? Yes. But as a third-party web app, it is even more important. Because if you do things early in the life cycle of the web page, you will be slowing down the web page that you're on. Another more general application of this rule is to modularize and lazy load as much as possible of your features. The Meebo bar has tons of features. And we know that most users don't use all the features right away, right? So instead of loading all the features right away, we wait until the user clicks sign on. Load the IM code then. Display a spinner. Give some feedback. We wait with loading the majority of the sharing code until the user actually starts to share. There are some more applications of this as well that Martin will go over.
This idea of breaking down your JavaScript based on what features the user needs can also be applied to the images in CSS fairly trivially, right? You break down your CSS and your images into separate payloads based on what feature they provide and load them when the user needs them. We have to be a little bit careful with the images, of course, because the HTTP requests that are incurred when you load a large number of images can really slow down the browser's network. So this is commonly solved with spriting and preloading images. There are numerous problems with spriting and preloading, especially as a third-party web app, particularly with preloading. Because preloading, you try to load the images when nothing else is happening. When you're on another website, you don't really know when nothing else is happening. And spriting is good because it concatenates the images together into single images, but it's very hard to automate. And you have to sort of inspect your CSS and figure out which images have a repeat set on them and which ones can be sprited. So what we've recommend doing for images is embedding them directly into the CSS. And you can do that with two techniques, data URIs and MHTML files. The idea is that you get the textual representation of the images. This is the base64 encoded version of your images. It's a text string. You can insert it directly into your CSS files. So you break up your CSS into smaller payloads based on what features that you need to load, and then you put your images inline in those files. And this works across all browsers. And I'm not going to go into the technical details of how you set up a system to do this, but we've written about it on the Meebo dev blog, so if you're interested, you should take a look there. The other thing we've investigated is not using images at all. All browsers currently support some form of vector graphics drawings, either through VML or SVG. Rendering vector graphics is a little bit slow, but for user interface elements, it's actually not that bad, because for the most part, you just do it once. For the Meebo bar, we render it once, and then that element just sits there. So here's a screenshot of what the Meebo bar looks like rendered with with vectors. The top is what it normally looks like, and the bottom is if you disable all images in the browser. You can see that our Chrome, there's some drop shadows and gradients that are all being rendered using vectors, which means that we don't have to download any CSS or images to draw that part of the UI. All that is done in the JavaScript. There's a few more things I'd like to talk about today. One is tools, and one is perceived performance. These are fairly small points. The tools you can learn about elsewhere. There's just a lot of tools out there, and we recommend you use them. The key ones that we wanted to point out today is the profilers and compilers are very important. There's profilers for all the browsers now. You can use them to look at how your JavaScript is running, particularly to optimize the loading of your application and the running of your algorithms in your application. And you should run that in all browsers, because all browsers have slightly different JavaScript engines, and the performance varies greatly. And the compilers are very advanced now. The Clojure compiler does a lot of cool tricks to optimize your code before it gets into the browser, not only minifying it, but also rewriting the code so that it runs faster. And finally, if you write a web app, you generally do a lot on the client, but you can actually do some on the server too. So don't forget about the servers. If your clients are running a lot of the same code and they're generating a lot of the same content, you should consider moving some of that off to the server if it's possible. As far as perceived performance goes, it's pretty hard to analyze this because the rigorous tools we have, automated testing, don't really do a good job of measuring what users think about your web app. So it's a good idea to always run your web app by your users and see what they think of it. For example, if you optimize your content with these tools and techniques, and your application is running asynchronously, non-blocking really fast, and you put it on a really slow website, then your content's going to load fairly instantly. It's going to look like you're slowing down the site, because the site will load after you. The same is true if you start slowing down your web app. If you're like, well, the browser's busy right now, let me draw part of my interface later. It may look to the user like it's broken, or it may look to like the user that your web app is running really slowly, even though you're really just sitting there doing nothing, waiting for the browser to be more available. Overall, though, it's important to remember that even if you use asynchronous and non-blocking techniques and defer your JavaScript and minimize how many network requests you're making, your web app is still going to slow down the page. There's only a finite amount of network bandwidth, and there's only so much the JavaScript engine can do. So just make sure to keep your payloads minimal and always monitor the performance of your web apps. So hopefully you can use these tools and techniques to make your web apps run faster and make the internet less likely to break. And we're going to post these tools and techniques online, I think, in our Meebo dev blog, so you can view these.
If you follow twitter.com/Meibo, we'll make sure to mention everything there. Thanks.
So far, whenever we've had a presentation that has a lot of technical content, it's usually followed up by a lot of technical questions. So does anybody have questions that they'd like to ask about some of the specific techniques that they've been covering here? If so, please come up to the mic. Or I will run this mic out to you.
We could
Yeah. Have you considered or done any evaluation of cross-origin resource sharing, implementing that on your servers and using XML HTTP request?
Do you know what that is? What is a cross-origin resource sharing?
It's some headers that you can add to your server that would grant the XML HTTP request access to across origins.
Yeah, we've looked at that for a lot of our comment requests. We currently don't use that. We have other ways of communicating with our servers cross-domain, so we don't actually need that. And that's only supported in the modern browsers, so it doesn't carry over to older browsers like IE7. So we use it if it's available, but it's not essential, I think.
Do you have another point?
Well, yeah, that kind of relates to the compatibility matrix. How far back does the iframe onload trick go back?
We currently support it back to IE6. So IE6, IE7, WebKit, Firefox.
Hi.
Hey.
So you mentioned the Iframe.js solution, dynamically creating an iframe as like the best solution. That works for you for the Meibo bar. Do you also recommend it for other third-party content trackers and ads? Can you comment on that? Do you have any experience with that, or?
I think it depends on how much your web app is doing. If you're just loading like a 10K JavaScript file that's going to track a page view, you probably don't need all of this. We would recommend it because if your server goes down, this technique won't affect the page. So it is a good idea to use it whenever possible. It sort of has diminishing returns, I think.
Yeah,
Okay.
but at the same time, if your server hangs, like doesn't go down completely, but just hangs on a response, then in a lot of browsers today, the browser, that hanging will block the rendering of the page in Firefox 3.5. It will block the rendering of the page if your head-appended script tag does not load, which is really, really bad.
It'll also block the onload event of the page as well.
Oh, yeah, right.
So any website that still uses the onload event rather than like a DOM content loaded event will suffer from
Thanks.
your scripts.
Thank you. Question?
Yeah. I have a question about the embedded images. You're saying that you will use the CSS embedded image to like render image, right? So in this way, it will not be able to take advantage of the browser cache. And the web app, the Meebo application is like almost rendered in all pages, right? So which means that those like small icons or those some image like thumbnails will not be reused in next request or in other page visit by using the data URLs.
The images are still cached because they're embedded in the CSS file, right? So the CSS file gets cached between page views. We load the same CSS file for the web app.
Okay, which means that you use separate the CSS file rather than inline those CSS files.
We split up the
Right.
CSS based on features. So when the user starts an IM session, we'll load the IM CSS for the UI that corresponds to instant messaging.
Okay. Yeah.
But that will have embedded images in there, and that CSS file will get cached. So in the next page view, if their IM session is still running, they'll just read that CSS file with all the images from the browser cache.
Okay. But the problem is not all major browsers support the embedded images, from the earlier version of IEs. So do you in the server side, do you decide where to render CSS, or in the client side you decide to render?
We actually use a variety of techniques so that we get cross-browser support.
Mm-hmm.
And then JavaScript, since it's dynamically loading these CSS files based on what the user's doing, can pull in the CSS file for that particular browser. So that we actually compile a separate browser CSS file for IE6, IE7, and then IE8 Firefox and Safari.
Okay. Thank you.
Thank you.
So you guys are trying to reduce additional HTTP requests and make them as small as possible. I'm curious if you do anything with respect to reducing your cookie size or the number of cookies that you might be setting, since they're going to go along with every single request.
Totally.
Right.
Yeah, sure. We use local storage. As much as possible, if you need some kind of state on the client side, don't put it in cookies unless your server needs to see them. That's what cookies are meant for. If the server does not need to see them, then use local storage. In IE, use user behaviors, which you can use to mimic local storage. There are plenty of really good wrappers out there in JavaScript that fall back on whatever is available in the browser. There's actually one, JS cache? Yeah.
Sure, and we don't have to put a slide.
Yeah, so there's one more interesting technique that we are experimenting with right now, which has to do with that. So a lot of web developers assume that once your site has loaded, then most of the content will be in cache the next time the page loads, right? It turns out that that's not always the case, mostly because a lot of the cache content gets evicted pretty easily, right? Especially if you browse around the web. The cache in browsers are surprisingly small compared to what we use the web browsers for today. So what you can do instead is use local storage and put your JavaScript in local storage. I don't really know. We don't know if this is a good idea yet or not. We're playing with it. We'd love feedback from the community. But one interesting extra benefit that we get, especially as a third-party web app, is that we know if our content is in cache or not, right? And we haven't. That's not a technique that people use because we've never had that before. But if you do have that, then you can ask yourself some interesting questions like, should we render the UI differently if we do have the cache or not, right? Should you add a button that is fake and does not actually register a click in the beginning just to make it look like the perceived performance is faster if you don't have it in cache, and delay the loading of the actual code until later if you know that it's not in cache?
What technique do you use to determine if the object is in cache or not?
We've built a wrapper around local storage that we can just dump JavaScript into. So we can just query the local storage to see whether or not a certain script is available in the local storage or not, and just eval it if it's there.
Particularly useful as a third-party web app because you can say, when the page loads, you can say, do I have this in cache? If I do, then you render it right away. Otherwise, wait a couple of seconds until the page has loaded. Get out of the page's way, right? That's what we need to do as third-party web apps. And then once it's loaded, go ahead and load our JavaScript, put it in cache. Next time the site loads, we know we have that content, can render right away.
An important point about that is it's the local storage on a Meibo.com domain. So if you visit 4 or 5 different sites, that cache will still be valid even though you're changing domains.
Right.
One more question for you. I saw on a slide up there that you talked about using Clojure compiler. I've seen a lot of people talk about using it. A lot of people have objections to various kinds of JavaScript rewriters. Any opinions on sort of best practices while you're using it?
We've experimented with using it more fully, but right now we're just using it at this very basic level, the simple optimizations compilation level. That alone works really well. As far as the advanced optimizations work, you have to annotate your code and change your coding style a little bit here and there. So it's worth it if you have the time to do it, I think.
Well, I don't see any more questions, so let's thank them. Thank you very much.
Thanks a lot, guys.